you've already seen slope. This is, we're going fast through this because you've seen it before. So our friend slope, another phrase for it is rate of change. On straight lines, it doesn't change. Does that make sense that it doesn't change? Okay, so when we in that video, they were talking about the price of gas. You go to a gas station, and the gas is, what might be an example of the price of gas? $4.90. $4.90 a gallon? Yeah, for $4.90 a gallon. So is it going to be $4.90 for your first gallon and then a different price for your next gallon?
Probably not.
Not probably not. It won't be. It will be the same price at that gas station, whatever that price that it is that you pay, it's going to be the same. Okay, so that slope there, when we're talking about slope, that slope doesn't change. Okay, so the rate of change is a rate of steady increase or decrease. And if we're talking about a linear graph means it's what shape? Somebody just said it. What kind of shape is it? It's a line. It has the word line in it, doesn't it? Okay, so it's a line. It's called slope when it's a linear graph. When it's a line, that rate of steady increase or decrease. So steady meaning it doesn't change, constant. So it's written as a fraction, not a mixed number. So for example, we would not write 1 1/5 as a slope. Let's say that the slope is 6/5. And it's a fraction of the vertical change. Vertical change is what direction? Up, which is your rise. And then horizontal is this direction, left to right. And that would be your run between any 2 points on the line. And is this going to change or is it going to remain the same for each? It's going to be the same. This remains the same or constant for any 2 points on the same line. So it is written as a fraction and simplest form. Do you remember the variable for slope? Letter. M. Okay, on to the next page. Okay, so types of slope. There's one type, what's that? Positive. So we go up to the right, and that's positive. What would this be? Negative. This one goes down to the right. That's a good sign. And then what's another type? 0. Which looks like this. It's flat. So the guy in the video was he was going up bleachers and down bleachers. And so then when he got to a 0 slope, he just was nowhere to go, just looking at his watch. And then there's undefined, which looks like this. So in that video, what was he trying to do for an undefined slope? Yeah, and he can't. I mean, like the wall is going straight up, so he can't. There's nothing he can do to climb up that wall. There. So, what about driving? Could you drive on a street that is like this? No. You hurt yourself. Can you ski on a slope that's like this? Can you ski on a slope like that? No, same thing. Dangerous. Okay, finding slope on the graph. M equals rise over run. So we are going to find we're going to find 2 points on the graph. Can they just be any 2 points on that line there? Can I use this point, for example, right here? Why is that not a point that I'm going to use? We don't know what the values are there. Those would be decimal values, and we can't tell just by looking at it. So we have to pick ones that are right at the corner, so we know what those values are. So this would be 1 point. Where would another one be? Where else? So this would be the other point, right at the corner. Does that make sense? Okay, so when we're finding rise over run, I'm going to go from this point to this point. So I'm rising up. So I'm going up here. So this would be 0, 1, 2, 3, 4, 5, 6, 7. Seven over 0, 1, 2, 3, 4. So my slope is 7/4. So what's the point on number 2? There's 1 point where there's several of them on this one. Here's another one. There's another one here, another one here. We can use any 2 of those. Okay, so it doesn't matter which 2 we choose. So to get from this point to the next point, we go, how much do we rise up? 1, and then we go left 3. So that would be -3. So this would be rise over 1 would be 1 over -3, which is -1/3. So I can put that negative on the top. I can put it on the side. I can put it on the bottom. Can I put it on both the top and the bottom? Correct. It would be positive if I put it on both the top and the bottom. So I don't want it to be that.
Well, I got this direction. Yeah.
So number 3. What kind of slope is that?
0.
Flat, so it's going to be 0. This is a 0 slope. Do you want me to show you using the right over run?
No, it's fine.
Would we go up at all to get from this point to this point? It'd be 0. So that's the rise. And then the run would be 1, 2, 3, 4. 0 over 4 is 0. So here's another one. Some of you might know right away what this one is also.
Undefined.
This is undefined. That's right. So if we go from this point to this point, it's up 2. And then do we go over it all? It's 2 over 0, which is undefined. We will talk about that when we go to find the slope given 2 points. Can I move on to the next one? Okay, so slope formula. We use find the slope between 2 points, x1, y1, and x2, y2. So the formula is y2 minus y1 over x2 minus x1. Now, do I have to start with y2?
Yes.
Should I start with y1? I actually can. I can start with y1. If I do, what do I have to do on the bottom? That's right, I have to do the x1 first. So those two need to be from the same point. So I like to think of it as the change in y over the change in x. This is a Greek letter called delta, and it means change. Change in y. Okay, so let's do the first one, naming this one x1, y1, x2, y2. Okay, so using our slope formula, we're going to do 3 minus 1. So we do our y's, 3 minus 1. And then because I chose 3 first, I have to choose 4 first on the bottom. So these have to be from the same point here. So 3 minus 1 is 2. 4 minus 1, 3. Okay, so what if instead of choosing the 3 first, if I chose the 1 first, will I still get the same slope? Let's try it over here. So I'm going to choose the 1 first. I'm going to do 1 minus 3. And because I chose the 1 first, I have to put the 1 first on the bottom. And then minus 4. So I get 1 minus 3 is -2, 1 minus 4, -3, which simplifies to 2/3. So it doesn't matter what order I go in, just so long as if I choose a value, I have to use that corresponding value for that point first in the denominator. Okay, so number 2, a little bit harder. Again, using that formula, I'm going to start with either y. So I'm going to start with the 4. Doesn't matter. I'm going to start with the 4. So it would be 4 minus what?
-2.
-2. Really common for students to put just 4 minus 2 there, but it's 4 minus a -2. Does that make sense? And then I'm put m equals. And since I chose 4 first, what do I have to choose first on the bottom?
-2.
-2. So this is the y value from the same point, and then minus 10. So in the numerator, minus a negative becomes a positive. So this is 6. And then when we have a minus, this is like addition of the opposite, which would be negative.
No,
So would it be?
it wouldn't be negative.
-2 plus -10, -12. So this would simplify to
1/2.
-1/2.
Yeah, why is
Okay, so it doesn't matter. I would still get that same answer if I started out by choosing the -2 first.
Right. Yeah, you're right. Why is there a negative on the 2?
Why is there a negative on the 12?
10.
On the 10? Because this was -2 minus 10, and so it's a little bit tricky to think about that is going to be equal to -12. So I like to change it to addition of the opposite. Like that. Good question. Okay, so let's do another one, and then I'll have you do one on your own. So what do we, somebody tell me what to do to find the slope on this one.
Negative.
Start with -5, so it's -5 minus 5. Since we chose -5 first, we have to choose -8 first in the denominator, and then that would be minus -4. So just be careful with those negatives. Really easy to forget to put that negative there. So minus a negative becomes plus a positive. This is like plus a negative, so this gives us negative 10 over negative 4, which simplifies to. Does that simplify to? Positive 5 over 2. Okay, go ahead and do the number 4 as a you try. You do this on your own.
Would this be right? Five is five.
Yeah, so then you just have to simplify it to these.
Minus negative 2.
Yeah, exactly.
What did you do? Did you get what negative? How did? Oh, do you say negative?
I didn't say it. It was actually.
I got no negative.
Yeah.
Well, it could be 10 minus negative 2.
Oh, wait, wait. Sorry.
She did that. I can't solve one.
Wait, is girl or fast? I like her. Like thinking fast. You said it was like forget. Oh. Thank you. But you can come up with practice after.
Negative 4 and 12. You literally have a rough.
And then I don't want to get too big. Like I want like tomorrow. Because then you get like.
Don't do it.
That always does.
Oh yes, sorry. I think said without. Oh, sometimes up. We won't know.
Figure out the word.
Figure it out. Figure it out.
We didn't know. We just stopped it.
Maybe it will be worth
So you should get negative 1/3 on that. Almost done. Hang in there. Questions on that before I move on to the last one? Okay. So finding the slope using data. I'm waiting for it to be quiet. Okay, it says you can use any two data points, just like points on a graph, but pick good points. Okay, so this first example here, what might two good points be to choose? Says we can choose any 2 points.
-3 and 9 and -9. Actually,
11. Like,
no. 3 and 7, 8. -3 and 9 and 15 and 3. Yeah.
So Sunny just said 3 and 7, 9 and 5. Good choice. Why are those good points to choose? No negatives. We don't want to deal with those negatives. We can avoid it. So then we would take our y minus y, 7 minus 5. Change in y's. So 7 minus 5 over, since we chose 7 first, we need to choose 3 first. So this goes together.
Oh.
3 minus 9. Does that make sense?
Yeah.
You're probably thinking of the y's. So then on the top, we get 2. What do we get on the bottom? -6. And this simplifies to?
1/3.
-1/3. Okay, one last thing that I want to show you. Actually, I'm gonna stop now.